All right, so I'm going to take two facts I know and put them together with our new product rule. So again, the product rule says if you have a derivative of the product of two functions, then that derivative is going to be a sum of products. So take the derivative of the first function, multiply by the original second function, add on the original first function times the derivative of the second function. And so we're going to apply that right now to the product of the two functions I have above, see what it looks like. And then we'll do a little tangent line test on it. So we're going to take the square root of x times the sine of x. And so according to my formula here, it says take the derivative of the first function, and I know that is 1 over twice the square root from prior experience. And then I multiply by the second function as is. And then I add on the original first function times the derivative of the second function, which I know from prior experience is cosine of x. Then we try to clean this up. Well, there's really not too much I can clean up. I have a denominator here, but not there. So I could try to deal with that, but I don't think it's really going to make life any prettier, but it's always worth trying. All right, so if I was going to add these two together, if I want to perform this addition, then I need a common denominator. And so what I would like this to have a denominator of twice the square root of x. So that means I have to multiply in the top twice the square root of x. And so that means my new version of this sucker would be 1 sine of x, so sine of x, plus 2, and then the square root times the square root in the top is an x, cosine of x, divided by twice the square root of x. All right, so I'm going to erase that red for a minute, and I'm going to ask you, does the first version seem any better than the second, or does the second seem better than the first? Which is simplified, I don't know, they both look like they use around the same amount of ink to me. Yeah, I don't know that this new version made my life any easier. So otherwise, what else could we do? We could try and factor the square root out, which will not make things any better in my opinion. We could use 1/2 powers instead, but that's not going to make things any better, I don't think. Yeah, the only way you can know if something simplifies is to try some algebra and just ask yourself, does that use less ink than the other way? All right, so how do I know if this is right? Well, I could go use a derivative calculator out there on the internet, and that's probably a cool thing. We'll look at those later. But I'm going to use my tangent line test. So I am going to pick an x value and make a tangent line. No matter what x value I pick here, this is going to be messy. So I'm going to pick an x value that works better with the sine than the square root. And that means, so now I'm going to find a tangent line, which is always good practice for us. Tangent line when x equals pi or pi over 2. Let's just go with pi. See what happens. All right, so if x equals pi, I need to know two things. I need to know what's my point, what's my y value there. Well, my original function was the square root times the sine. So y is the square root of pi times the sine of pi. And the sine of pi is 1, right? So that should just be the square root of pi. We'll test that on a calculator in a second. So that means the point of tangency is pi, comma, square root of pi. What's the slope at that point? Well, that's what this function here tells me, or the other version of it, whichever you like. I'm going to go with that one. Why not? I made the effort to do it. So my slope of the tangent line is going to be the sine of pi plus 2 pi cosine of pi divided by the square, or twice the square root of pi. All right, so what do we know about this? We know that the sine of pi is 1, And the cosine of pi is 0. Oh shit, no, that's not true, I lied. Sine of pi is 0. Cosine of pi is -1. All right, so I got errors here already. This one is a 0, and this one would be a -1. And this up here, sine of pi, should have been a 0. So that should be a 0, and that should be a 0. So pi 0. We'll look at the graph and make sure. All right, so what's the slope then? That's gone. That's a -1. So I get -2 pi over twice the square root of pi. And those divide out. And pi divided by its square root. To clean that up, we multiply top and bottom by the square root of pi. And so that gives me -pi square root of pi over, that's supposed to be a pi there, not an x. Square root of pi times square root of pi is pi. Those pi's divide out. So I think the slope should be negative square root of pi. So then I think my line should be y minus 0 equals negative square root of pi times x minus pi. If you want it to look like y equals mx plus b, which is fine, that would be distributing up here. Minus 0, who cares? So negative square root of pi. Negative times a negative is a plus pi square root of pi plus. All right, let's see if that looks real. Do you need to know the derivative of the sine of x is the cosine of x? Yes, that is a good thing to memorize. And that was definitely in the book in section 3.1 or 3.2. And there's a video in my playlist where I prove it. We'll do more with just trig derivatives in another section soon, I promise. All right, let me see. I need my grapher. So let's whip out Desmos, say, and I want to see the function f of x equals the square root of x. Get outside the square root and then multiply by the, what do they say, sine to start with. And it's a cute little function right there. And I picked the point pi, so that should be right here. Pi 0, there's my point, and I should have a negative slope through there. And I think the slope is, what was it, negative square root of pi? So let's test it. So I'm just going to double check that point by going, I want to see the point parentheses, pi comma f of pi, which is now plotted right there in blue. And I think the tangent line is y equals negative square root of pi times x. And then, let's see, what did I get? I forgot now. Was it plus the square root of pi? Where's my notes? Plus pi square root of pi. In my messy notes there. So plus pi square root of pi. Yeah. Okay, now it looks like it hits more than once. And tangent lines on these functions, these wavy functions, are going to have to do that because they curve back up. But if I zoom in here, I should see its tangent at that point there. So I'm going to just zoom in on that point and see what we see. So ignoring that other point of intersection there, what I should see is that the green curve is above the red. So the green line is above the red curve, and I can see that here near the point pi 0. But because the red curve turns around, it hits its tangent line again. Can't do anything about that. It's fact of reality here. Change direction and hit itself, or hit its tangent. All right, yeah, that worked. Okay, so just evidence, fun. Let's see. I think that's good on that one.